Namaste and welcome to CADEC learning series. In this video, we'll define shape variables, which are also called classifications, to the simple conveyor product class. In previous video, we defined size variables and checked calculations. We used this conveyor, but that conveyor only has size variations. In reality, any company's product has different shape variations also, something like this. In this conveyor example, we can consider roller, belt, or slat conveyor. It can be horizontal or inclined conveyor. It can be straight path or curved conveyor. It can be powerized or manual conveyor. There can be multiple combinations of these classifications, and generating combination models is the real power of CADEC. What looks very complicated and difficult to manage becomes easy and manageable with a tool like CADEC. Let's see that in this video. Again, in this video, we'll not create any CAD model, but we'll only plan shape and size variables and their calculations. This planning makes the model creation easy and systematic. Let's go to SolidWorks. I'll open our product class, which is simple conveyor. And these are the size variables which we had created in the last video. First, we'll add shape variables. So shape variables are the ways in which different functionalities can be added or removed from the design. So first I'll create a shape variable called method. In that we can have roller, belt, slat. The another shape variable is slope. So I can have horizontal and inclined. Third shape variable is path. So the options are straight and curved. And fourth shape variable is operation. The options are powerized or manual. Now we'll make some modifications to the variable table. So I've added some variables and made some changes. Some variables I have added are I've added belt width and belt length, then drive roller diameter, that depends on total component weight which are there on the slat or belt at any time, and similarly drive sprocket diameter, and from that I have calculated the circumference of roller and sprocket, and which is added to the belt length. So conveyor length into 2 plus drive roller circumference is belt length. Then I made one change in the leg numbers. If the uh, conveyor is inclined, then the conveyor length is multiplied by the cos of the inclination angle to find the horizontal length for calculating the leg pitch. This is added. Then I have created one more variable, conveyor length millimeter override. Earlier the conveyor length was calculated, but if the conveyor is powerized, then that is okay. But if the because the conveyor length was speed into time, but if the conveyor is manual, then the user will have to specify this conveyor length override. Then slat width and belt width are calculated. Then if the uh, conveyor is curved, then the curve center length and the taper roller's number is calculated. Uh, if the conveyor is curved, then we'll use taper rollers. Start height and end height are added because they are relevant only for inclined conveyor. And inclined angle, degrees, and curve center radius they are added, uh, and curve angle in degrees they are added for uh, curved conveyor. So with this, we have made all the changes to the uh, variable table. I'll save this. So now the next task is we'll add some rules because we have added a lot of variables and some of the variables may not be relevant for a particular case. So first we'll make the dependency between shape variables. So first, if slope is inclined, then we'll uh, okay. We'll make some shape specific shapes. If path is curved, then we'll show only rollers. If slope is inclined, then path will be only straight. So some of these variable dependencies will define through calculation rules. So I'll go to shape specific shape. I'll make some rules here. They will be like if the whatever classifications we had defined, they will be available in the drop down here. So if the slope is inclined, then we can show the path as only straight because inclined and curved we don't want to cover in this product. Similarly, when the path is curved, we'll use only roller. So the method will be only roller because we don't want to have a curved belt or curved slat. Similarly, when the method is belt, we want to have only motorized conveyor, only powerized conveyor. And similarly, if the method is slat, again we want to have only powerized conveyor. So we have made all the shape specific shapes and I am saving this. Then we'll have to make some option specific input specifications because some variables may not be relevant. Some input variables may not be relevant for some of the options that we have chosen. So if the method is belt, then We don't need the size variables, start gap override and end gap override. Same for slat also. Then if the slope is inclined, then we don't need conveyor height, because in that case we'll be specifying conveyor start height and end height. They will be different. So if the slope is horizontal, then we don't need the start and end height as well as the inclined angle also. So start height, end height, and inclination angle, they will be hidden. Then if the path is straight, then we don't need the curve related uh, variables. They are the curve center radius, curve angle in degrees. These two will not be required. Then if the operation is manual, then we don't need the time and speed. This speed and time is not required. And if the operation is powerized, then we don't need the conveyor length override variable. Yeah, so we have saved this. So we have now completed all our shape specific shape and shape specific input definitions, and now we are ready for testing this example. I'll use this. So we have a lot of variables now. So if I use, let's say, roller, then I have, say, horizontal. Then suppose I want straight, operation is powerized. Then conveyor height, let's say 600. Component length, let's say 400. Component width 300. Compound weight 5 kg. Speed 1. Travel time. Then suppose these override values I don't want to give. I want to calculate this. So it is calculated. This is same as our previous example. Suppose we want belt conveyor and we take inclined slope, then the path is only straight because we have defined that if it is inclined then it cannot be curved. So we have only straight path and inclined, and the operation is only powerized. Suppose we keep the same component length and width and same component weight. Now component overhang O, this is, I'll not specify this. It now asks the start height and end height because it is required for incline. Let's say I give 400 and 900, and it needs some angle in degrees, so I give 30 degrees. So now in this case, it has calculated the required conveyor length is 8,000. Then the leg pitch is 1385, roller pitch 149. Suppose we choose roller and horizontal, then we have option of straight and curved. And suppose we choose powerized here and component overhang, so I'll not specify. Then curve, I need to give some curve center radius. So and curve angle in degrees, let's say 90. In that case, the curve center length is 2300 and taper roller number is 17. Okay. So this is how we have now added our shape variables and also modified the size variables. And now this is the formulator. Thank you.